Happy Tuesday, my Reno Valley peeps. Hey, today we are going to continue our discussion on patterns with powers. Only today we are going to put a real life twist to it. So do you remember on the very first day of class, we had this diagram where we had people starting with 1, branching off to 2. From this one, it branched off to 2 more. And that pattern just kept continuing. Now, this is assuming that the growth of this virus that we are experiencing is constantly doubling. I don't know if they have actually figured out an equation for it, but this is a very simple example of exponential growth. So what we're going to talk about today are patterns in powers of 2, using a real life emphasis. So basically what we have here is this guy right here has the coronavirus, and at this point has 0 interactions with people. Let's see if I can get that all on there. If he is staying at home, not interacting with anybody, the virus stays here. But if he goes out and interacts with at least 2 people, this would be 1 interaction. Now we have affected, or could have affected, 2 people. The second wave of interactions would then double again. Now we have maybe possibly infected 4 people. And with as contagious as this virus is, it's highly possible. So when we were looking at that diagram on our first day, the reason for social distancing is because of the exponential growth. If we limit where we go, we can possibly wipe out half of our interactions. So let's look at this in a math lens. Let's go ahead and make a 2-column notes here. And we're going to say that this virus is doubling, and we want to know how many people would be affected by each interaction. This X exponent stands for our interactions, the number of interactions. So if we have 0 interactions, and I think I'm going to add another column here. We'll label this one X. If we have 0 interactions, that means it would be 2 to the 0 power, which would mean 1 person. I think let's go ahead and put number of people up here just so that we can kind of keep track of what we're talking about. So if we have 0 interactions, that would be 2 to the 0 power. Just 1 person would have been affected. So this would be our 2 to the 0. Oh, couldn't see that. Let's double check. There we go. If that person would have had 1 interaction, 2 people would have been affected, which would have been this line of our chart. 2 interactions would be 2 to the 2nd power, this part of our chart here, which would mean 4 people. And we could continue on. If we had 3 interactions, 2 to the 3rd would be 8. 4 interactions, 2 to the 4th would be 16 people. And you can see how it just really starts to grow. This would be our exponential growth. So now what I want to do is I want to look at another Let me flip my paper here. Get centered here. I would like to look at another real life example of these patterns in the power of 2. And it's something we do all the time, and it's folding paper. Oh, let's double check here. It's just like when I'm at school. Whoops. There we go. Okay, let's get this set up first, and then we'll actually do our experiment. If you have a piece of paper lying around, an extra one, go ahead and grab that as well so you can do this with me. I know several of you mentioned that you wanted hands-on experiences. This would be an opportunity to get your hands on a piece of paper and actually see it. So our first column here is going to be the number of folds that we're going to put into our piece of paper. The second column is going to be our power of 2, so 2 to the x. And our third column will be the number of sections that results from these folds. I think you're going to see some similarities to our coronavirus chart from the previous page. So if we don't have any folds, if we just have a piece of paper, here's my piece of paper. There are 0 folds, so that would be 2 to the 0 power. How many sections of paper do I have? Well, I only have 1 section of paper. However, when I go ahead and put in my first fold, go ahead and fold your paper in half, hamburger style. I now have, this is hard to see, I know, but I now have 2 sections in my piece of paper. 2 to the first power would give me the 2 sections. Let's go ahead and put another fold in here. So we're going to fold it again, hamburger style. I'll just go ahead and complete this while I'm here. 2 to the second power. So I have my half now. Here's my whole. I folded it once. Now I'm going to fold it again. And how many total sections does my piece of paper have now? Well, it has 4. If I were to create a third fold, and I unfold it, I would now see that I have a total of 8 sections. If I fold it back up and I do it one more time, if I put in my 4th fold, how many sections will I end up getting? You are correct. I will get 16 total sections. You should have 4 going down one side and 4 sections going across. 4 times 4 is 16. So now let's look to see how those negative exponents can actually be shown with folding paper. I'm going to create another 3-column chart. Am I still on? I am. And my first column is going to be the number of divisions. My mathematical formula will be 2 to the negative x. Because if you remember, when we have a negative exponent, we're actually dividing by this base that number of times. And then my last column is going to be the area of one section. Okay. Now I don't have another piece of paper, so I'm going to have to use this one. Well, let's see. Let me just go grab a different piece of paper here. We'll just use a piece of notebook paper this time. Right now, I have not divided it or folded it at all. So I'm back to my 2 to the 0 power, and my area of my one section is one whole piece of paper. Let's go ahead and put in one fold or one division. And now keep it folded like this so you can see what we're talking about. I have one division. You will see that it's a negative x. What is the area of this one section now that I have showing to me? I'm not going to unfold it. What is the area of this section? Well, it is 1/2 of that whole paper. Or it is 1 divided by 2 one time. 1 divided by 2 one time. Let's go ahead and put in another division or another fold. It's getting smaller. 2 to the negative 2 power would be 1 divided by 2 times. So 2 times 2. Remember, this negative means we are dividing. So 1 divided by 2 times 2, which would actually be 1/4. If you were to open up your paper, one section of this paper is actually only 1/4 of the entire page. Go ahead and refold it back so that we have a 1/4. And we're going to put in our third fold, 2 to the negative 1/3. We're going to make our third fold, which means 1 divided by 2 times 2 times 2, which would be 1/8. Is one of your sections 1/8 of your entire piece of paper? You should see in your paper 1, 2, 3, 4, 5, 6, 7, 8 sections. So one section is 1 out of the 8 total of the page. So there you have it. Just some real life examples where you can see how positive and negative exponents actually represent some situations, particularly the one that we are in right now, COVID-19. All you needed to do for this lesson was, again, take notes. There are 2 questions on Google Classroom that you need to go and answer. Once you get those answered, you are done for your math homework for the day. Have a great day. Bye.